Past me literally got into this situation the other day. I received a timestamp like this. I looked at it and said, it's a little long, but it's probably just the Unix timestamp. So I took to the internet, stopped my important research, and since I was working with Spark and data frames, I took to this website and looked at its date conversions. Then I started questioning myself. I thought I had a Unix timestamp, but it doesn't look right. Maybe it's UTC, or is that the one I want to convert to? Wait, what about ISO date times? With the help of this video, I'm not going to let that happen again, and hopefully it can help others too. Unix epoch time is usually how many seconds has passed since January 1st, 1970. Why January 1st, 1970? I don't know, but they usually look like this. Unless it looks like this. Again, this is the time since January 1st, however this is in milliseconds and not seconds. Most programming languages have a function that can convert the Unix epoch from seconds to a more human-readable date. However, this is not true for the milliseconds version of the format. To get around this, you could just convert the milliseconds to seconds first by dividing by 1000.0. Fun fact, on the 19th of January 2038 at 3:14:08, it will be IT second go at the Mendelian bug. Basically, too many seconds will have passed since 1st of January 1970 for a 32-bit system to handle. This just means some systems might poop themselves, but only a little. UTC is basically the standard time used by the world. It is not affected by a time zone, nor is it a time zone itself. UTC is often interchanged and confused with GMT. Well, they are essentially the same time. GMT even used to be the world standard. However, this is no longer the case. At this point, GMT is a time zone, whereas UTC isn't. GMT isn't even used all year round. For instance, the UK switches to BST during daylight saving time to account for the extra hour. UTC is not interchangeable. ISO 8601, commonly referred to as just ISO, is a standardized way of presenting the date and time, and it looks like this. This is important, especially if you are communicating and sending data internationally. For example, this is either 10th of January 1991 or the 1st of October 1991, depending on where you live. So the ISO date and time format was created to avoid all confusion. So back to this. The ISO date and time format classically comprises of a date in the format of year, month and day, a time marked with a capital T in the format of hours, minutes, seconds and milliseconds, and a time zone. Here it's marked with a capital Z. This means the time is not altered by a time zone. The Z stands for Zulu time, which was another name for GMT, and if you remember a couple of slides ago, that used to be the world standard. If a time zone should apply, then the ISO time is represented with a plus or minus and how much time the time zone affects UTC time. The example here is UTC time plus 1 hour. As a quick side note, ISO 8601 is only one version of the ISO standard, but the others are rolled, so who cares? Also, the International Organization of Standardization have a bunch of standards that don't involve date and time. Sweet links in the description if you want to kickstart some research. Okay, future me, get back to work. It's Zulu time.